Hello, people at home. We're going to work on solving equations with variables on both sides of the equal sign this week. Really big concept. We worked on solving equations with fractions last week. I'm going to give you just this video as a warm-up. I want you to pause here and see if you remember how to solve or how to simplify these first 6 problems. So hit pause and give these a try. Write them down on paper or on your whiteboard, and I'll reveal the answer in a minute. So a few things to watch out for. One is, of course, watching our signs when we distribute, remembering that this would give us, minus 7x plus 21 as we distribute the negative 7 to the negative 3. Remembering how to multiply fractions. 3 goes into 6 twice, and 2 times 1 is 2x. 3 goes into 9 3 times. 3 times 1 is 3. That's where that came from. Remembering again that there's a negative 1 in front of that parenthesis. So that gives us an answer of 17 minus x. That would be 15 minus x plus 2 would be 17 minus x. I hope by now we can answer number 5. And remember, I gave you that method last week of clearing out fractions. So for a question like number 6, I would multiply both sides by 3. 3 goes into 3 once, and 1 times 1 is 1x. 3 goes into 3 once, 1 times 1 is minus 1. And then 3 times the 9 is 27. And we solve from there, okay? So taking all of those ideas into this lesson today. Our objective today is to solve equations with that have the variables on both sides of the equal sign. We're going to talk about these terms identity, contraction tomorrow, not or next time, not our main goal today. To solve an equation with variables on both sides, we're going to use inverse operations to collect the variable terms on one side of the equation. And that's the important part, is the variable needs to be on one side, the number needs to be on the other side. And our book says, this PowerPoint is right from the book, equations are often easier to solve when the variable has a positive coefficient. Keep this in mind when deciding on which terms to collect, which side to collect the variables. Here's what that means. We have an equation something like this. 7n minus 2 equals 5n plus 6. So we need to start moving things around. I'm going to try to convince you to move the variable first. Either move the variable that's on the left over to the right, or move the variable that's on the right over to the left. And the phrase I like to use when we solve these equations is think ahead a couple of steps. What's going to make your last step easier? So we're going to leave the numbers alone for right now. And when we leave the numbers alone, what we're going to do is move the variables. Is it better for me to move that 5n or for me to move the 7n? Well, let's see. If I want to move the 7n, I would, because it's a positive 7n, I would subtract that 7n from both sides. So I could say minus 7n, and then I want to subtract it from its like term on the other side, which would be the 5n. And I can do that. That's okay. The difficulty is, well, let me run through the problem. 7n minus 7n, that goes away. That we picked subtracting that 7n because it's the inverse operation. It will go away. Gives me minus 2 equals, now here's where I have to watch my signs. 5n minus 7n, that's negative 2n plus 6. And I can solve from here. My next step would be subtracting 6 from both sides. But as I do this, I start to get worried about the signs. Let's see, negative 2 minus 6. I know that's negative 8 equals negative 2n. And then my last step would be to divide by negative 2. And it's this last step that we as algebra teachers, we see the most number of mistakes in. I would get n equals negative 8 divided by negative 2 is positive 4. So we could do that. That's an okay way to solve that problem. We certainly got the right answer because I was really careful with my signs. However, I'm going to show you a different way that's going to make the end of this problem a little bit easier. We have fewer mistakes when we do it this way. So if instead of subtracting the 7n from both sides, we started by subtracting the 5n from both sides, now what happens is, if I plan ahead, I get a positive 2n. Minus 2 equals 6. And now I can add the 2 2n equals 8, and divide by the 2, and n equals 4. So planning ahead a couple of steps gets me to the point where in my last step, I'm dividing by a positive number, and I'm going to make fewer mistakes. I'm going to remember, I don't have to worry about remembering that negative sign because the negative sign isn't there. So plan ahead a couple of steps is our goal. So let me just pull up another example. So I have 3n minus 6 equals 5n plus 7, and I want you to think about leaving the numbers alone. Again, let's leave the 6 and the 7 alone. Let's think about moving the variables first. And as we do that, which one would be better for us to move first? I could move the 5n by subtracting it from both sides. But if I do that, I'm going to end up with a negative number. If I subtract the 3n from both sides, now I end up with 3n's gone, minus 6 equals, and I have a positive 2n. So it's your choice, but the goal is to think ahead and do this smartly. Do this so that the end game, the end of your problem is better for you because you've planned ahead a little bit. All right, and then we would subtract 7. Minus 6 minus 7 is negative 13 equals 2n. And then I would divide by the positive 2, and I would get negative 13 over 2. And if you want to change that into negative 6.5 or negative 6.5, all of those are good. Okay, so it's a matter of strategic planning here, thinking about the best way to end the problem before you even start the problem. Here's a little bit longer one. Okay, so now we've got a problem that says solve 0.5 plus 0.3y equals 0.7y minus 0.3. And we can do the same thing here, right? Plan ahead a little bit. Again, I'm thinking about, am I moving the 0.3y or am I going to move the 0.7y? Well, I want to move the 0.3y because, again, it's going to give me a positive value as I subtract it out. So minus 0.3y minus 0.3y. Again, subtracting it from its like term on both sides of the equal sign gives me 0.5 equals 0.4y minus 0.3. And then I could add the 0.3, add the 0.3, remembering that that's 0.8. I line up my decimals, equals 0.4y. And then even though it's a decimal, I can still divide by the 0.4. And y would equal 2. So again, a little strategic planning at the beginning makes the end of the problem easier. It says to solve more complicated equations, you may need to simplify by using distributive property or combining like terms. And that's very true. As these problems get longer, we need to clean up the left side and the right side before we start to solve. So if I look at this on the left-hand side, this is a big long equation. On the left-hand side, I notice I have a couple of like terms, and I should rewrite this left-hand side with those like terms combined. So that would be 4 minus 6a plus 4a is minus 2a equals. On the right, I have to distribute first. So let's see, that's minus 1 minus 35, multiplying here, and then plus 10a. And I still have like terms. Minus 1 and minus 35 are like terms. So that's minus 36 plus 10a. So distribute, then combine like terms. And now, from this line down, it's just like the problems we've been doing. There's an a, and there's an a. And again, strategic planning, which one of those is better to move? I want you to pause here, hit pause, try this problem, and I'll work it out with you in a minute. Try it on your paper first. So I'm going to choose to add the 2a to both sides. That would give me 4 equals negative 36 plus 12a. And then I would add 36 to both sides. That would give me 40 equals 12a. And I can divide by 12. And again, I have a fraction here. I have it's not a whole number, but I can simplify that. 40 and 12 are both divisible by 4. So if I simplify, I get a equals 10 over 3, or 3.3 repeating. Okay, so again, it's distribute first, combine any like terms on the left side and the right side before you start moving variables around. And here's one with fractions and distributing. So we should distribute before we clear out any fractions. So let me multiply here. That would be 1/2 b plus half of 6 is 3 equals 3/2 b minus 1. And here's one of those problems with a fraction. If only we had a way to get rid of fractions. Oh, we do, that's right. We could multiply both sides by the common denominator of all those fractions, which in this case would be 2. So I'm going to multiply by 2 on the left and 2 on the right. 2 times 1/2 b, 2 goes into 2 once, and I don't know why that keeps happening. 1 times 1 is 1b. Multiplying by that 3, that would be plus 6, equals 2 goes into 2 once, 1 times 3 is 3b minus 2. And now again, strategic planning here, which one of those b's is better to move first? I would say it's better to subtract 1b out. We get 6 equals 2b minus 2. Add the 2. 8 equals 2b, and divide by 2, so b equals 4. Okay, so it's a little bit of strategic planning is the whole idea of today's lesson. And I'm going to have you pause, try this problem, and then we are about done for the day. So pause, give it a shot, and I'll show you the steps. All right, answer to this problem. Did you get x equals -2? Pause there, read through the problem if you need to, and that's it. All right, so just go and practice some practice problems, and we'll talk to you on Zoom tomorrow. Bye-bye.